Hello, this is Yahya. Today we're going to be talking about cascaded multi-level inverters. Starting ahead by mentioning a brief history about the cascaded multi-level inverters and when it was first introduced. So basically multi-level inverters were first discussed in the mid 70s. The first patent describing the inverter topology that is capable of producing multi-level voltages from several DC sources was first introduced by Baker and Bannister in 1975. Topology means is actually from several DC sources through a certain connection, certain network of switches, they would produce a sinusoidal-like waveform which is called a multi-level voltage waveform that mimics the job of a typical inverter. So what they've introduced was significantly better than the inverter because of several features. One main one of them is that they reduce harmonics in an insanely manner. Another feature is that they get rid completely of the transformer. Uh, Work after Baker and Bannister's work in 1975, it was followed up by roughly 120 papers as a continuation of their works, and most of that research were focused on the cascaded H-bridge multi-level inverters, or also known as cascaded multi-level inverters. Uh, So after our brief introduction to cascaded multi-level inverters, I would like to go through a little bit of comparison. Whereas the old systems used to use classic just two-level converters, while as the more common ones nowadays, or ever since 1975, are the multi-level converters, which have three types: the diode clamped, and flying capacitor, and cascaded multi-level inverters. So now we're going to talk about the main features of the multi-level inverters that other previous inverters do not have, and that multi-level inverters have advantage over them with these features. First of all, that the more the levels you have in a multi-level inverter, the more voltage output that you get. Another aspect to this, that multi-level inverters can also be applied in high power. And another main feature of the multi-level inverter is that the output voltage of the multi-level inverter is mainly controlled by the DC bus or VDC, and we can control that by the variable DC links, which means by the many DC sources that we have as an input to the multi-level inverter. This is a graph that represents the comparison between a 2-level, 3-level, and a 9-level inverters, which we can see the higher the level of the inverter, the more sinusoidal-like it gets, the more specific, the more accurate result that we get in the inverter. So this is where we get more specific about the cascaded multi-level inverters. First of all, we're going to discover how it works. And as we can see from the left-hand side, each level of the multi-level inverter, which is 4 levels in this case, have 4 switches to do the operations of passing or blocking the signal accordingly. Next thing we're going to talk about are the main features of the cascaded multi-level inverter. And the first thing is that the cascaded multi-level inverters needs separate DC sources, and that will be very helpful in applications like renewable energy. And second feature is that It requires the least number of components among the other two multi-level inverters that were mentioned earlier. And the third feature is that, of course, the applications are limited because you have to have separate DC sources in order to work out this multi-level inverter. So moving on to the influence of daily life, cascaded multi-level inverter, or generally the multi-level inverters. As we know that harmonics are something that is undesirable in a power system, but unfortunately most of the inverters and most of the power systems are facing until this day issues with harmonics, challenges, and they're researching how to solve these issues. So what cascaded multi-level inverters have brought us is more safety due to their limitations of harmonics in a circuit. No matter how many levels do you have in a multi-level cascaded inverter. So here I'm just going to review briefly on the dangers of harmonics. So based on a study by Havas and Stitzer, basically harmonics will produce electromagnetic fields, and continuous exposure, so that means residential areas around let's say power lines and such, continuous exposure to electromagnetic fields can result in serious results. That's all I have to say about this. Thank you very much.